All right. So example 3, we're going to sketch a graph of f of x equals 2 over 5 minus x and state its domain. So we're going to use those 8 steps. So our first one, remember, is to find the domain. How do we find domain? Set the denominator not equal to 0. So 5 minus x cannot equal 0. Solve for x. How? I'm going to move the x over. You could move the 5 and then divide by -1. That would do the same thing. So we get 5 cannot equal x, which means x cannot equal 5. So what's my domain? From -infinity to 5, union, and then 5 to infinity.
Why are the union things just happening?
All right. Step 2, remember your vertical asymptotes and your holes. So we need to see, can we factor anything in this problem? We've got the 2 on top. Can we factor that? What about the 5 minus x? No. So remember, holes are your canceled factors. So does anything cancel? Nope. So that means there's none. And vertical asymptote then is where your denominator, your uncanceled factors are equal to 0, which the uncanceled factor in the denominator is 5 minus x. So what do we get when we set that equal to 0? X equals 5. Guys, these two together will make up your restriction in your domain, okay? So if there's no horizontal, if there's no holes, then that means it's all vertical asymptote. So any restriction we have there in the domain would be a vertical asymptote.
Can you explain that a little bit more? Sorry, I didn't understand that at all.
All right, step 3 is your horizontal asymptote. How do we find horizontal asymptote?
The ABUC thing, like we gotta look at which one has the highest coefficient.
The highest power of x. So in the top here, what's the power of x? There's not an x, so it's a 0. What about on bottom? It's a 1. So it's bigger on bottom, so we use no. Since it's on bottom, what does that O represent? Y equals 0. Step 4 is that slant asymptote. Well, we haven't even talked about that yet. So for now, we're going to put none.
Is there one?
No, there's not. Okay, step 5 is your x-intercept. You know what? I'm going to move this over to this side there so everybody can see it better. All right, so 5 is your x-intercept. How do you find an x-intercept? All right, it's the entire function set equal to 0 because there's a shortcut. Because think about this. I'm going to write it down this time. If I have 2 over 5 minus x, and I set that equal to 0, what are we going to do? We're going to multiply by that 5 minus x, aren't we, to get rid of the fraction? So on the left side, we get 2 equals, it's always on this other side going to be 0 times whatever. What is 0 times anything? 0. So where did this 2 come from? Numerator. So the shortcut is, when we're dealing with rational function, it's just our numerator set equal to 0. Okay? But then we have to deal with the fact that 2 is equal to 0. Do I have an x value, or an x to solve for? No. So this can't happen, so that means on this one that there's not one.
So we would literally just put none.
You would put none.
Like we don't have to deal with an imaginary one or anything like that.
Right.
Sweet.
All right, so this one's none. Okay, 6 is my y-intercept. How do you find a y-intercept?
Put the x equals 0.
Good, x equals 0. So let's see, we get 2 over 5 minus 0 for my y. So we get 2 over 5. So let's write that as an ordered pair. How do you write that? 0 and 2/5?
Yeah.
Alright guys, something we did not do, and we should have done back when we did our horizontal asymptote. Are you listening? We said that there was one, but we didn't check to see if it crossed in the middle somewhere, okay? So we need to check. Let's go back and let's check that horizontal asymptote. To find out if it crosses, remember we set the equation equal to our horizontal asymptote, and we said it was 0. So when I set that equal to 0 and I solve, we come out just like that x-intercept, don't we? So if you multiply by that 5 minus x, you end up with 2 equals 0. Because this is not true, that means it does not cross the horizontal asymptote. I forgot to do that piece. Alright, so I'm going to go to my next slide here so I can see my graph. I'm going to recap it real quick. So we said we had a vertical asymptote at x equals 5, right? We said there were no holes. We said we had a horizontal asymptote at y equals 0 and that it did not cross. We said there was no slant asymptote. There was no x-intercept. We said we had a y-intercept at, what is that, 2 over 5? 0 and 2/5. Alright, so we're ready to make our table. Well, sometimes our table is easier to make if we go ahead and graph what we know. So my interval table is going to look like this. It's going to have my interval. That's what the INT stands for. It's going to have an x value that I'm going to pick that's in that interval. We're going to plug it in and get a y value, and then we're going to look at the sign of it. And we're going to use that x and y to help us see our quadrant, or not our quadrant, excuse me, our piece of it that we're going to graph in. But let's go ahead and let's graph what we have. We have vertical asymptote at x equals 5, so let's go graph it. Remember, asymptotes are going to be dashed lines because they're not really part of my graph, but they help shape my graph. I have a horizontal asymptote at y equals 0. I have no slant asymptote, no x-intercept, and I have a y-intercept at 0 and 2/5. Alright, so to create my interval table, my intervals are formed by my x-intercepts and the vertical asymptotes. So an easy way is to look at the x-axis. Okay? Because it's kind of that number line, and it's broken up by the x-intercepts and the vertical asymptotes. Well, my intervals will always start at negative infinity, and they're always going to end at positive infinity. It's kind of like the domain, but it's not just the vertical asymptotes now. It also includes the x-intercepts, okay? But it won't include holes if we had any. So if I look on here, as I'm going across my x-axis, I'm starting over here at the negative infinity. I'm going towards the right. What's the first thing we have that affects it? That vertical asymptote, isn't it? We don't have any x-intercepts, so it's going to be there at the 5. And then from the 5, as I go to the right, I go, there's nothing else to stop me, so I keep going all the way to positive infinity. Oh, I didn't write my infinity here. Alright, so let's pick an x value that's in that first interval, from negative infinity to 5. What's an x value that's in that?
0.
0? And what about from 5 to infinity? 6. Alright, so let's plug in 0 for x And what do we get for our y? Should have got 2/5, right? Isn't that our y-intercept? When x is 0? So I know that that's going to be a positive 2/5. So the reason we put the sign there, well, there's two reasons. One is because of our next lesson that we're going to be doing, the inequalities. We want to know for sure if it's positive or negative. And the second reason is, if my y is positive, is it going to be graphed above or below that x-axis? Above it, okay? So let's go ahead and do the next one. So plug in that 6. And so we get, I'm going to show my work here. So I get 2 over 5 minus 6. So 2 over negative 1, which is negative 2. And so that's negative. Now we can actually plot the points that we just found. If I plot 0 and 2/5, I've already got that point on here, don't I? But that means I'm going to draw my graph over in that area, and it's shaped by those asymptotes. So as I draw to the left, it's going to get close to that horizontal, but is it going to cross it? No. And as I draw to the right, I see there's that vertical asymptote there, which is going to force my graph to go up. And then I had the ordered pair 6, negative 2. So I can go and plot that. And then the same thing, as I graph towards the left, as I come out and go towards the left of that point, it's going to force me to go down. And as I go to the right, I'm going up to the right, but that asymptote there is going to force me to go to the right like that. And so there's my graph.